Welcome to the Prosthetics and Orthotics Podcast with Joris Peels and Brent Wright, where we explore the latest developments and advancements in using 3D printing technology to create custom prostheses and orthoses. From in-depth interviews with leading industry experts, to case studies, to patient experiences, we delve into the exciting and innovative world of 3D printing and its role in the field of prosthetics and orthotics. Join us as we journey into the future of personalized healthcare with 3D printing.
Hello everyone, my name is Joris Peels and this is the Prosthetics and Orthotics Podcast with Brent Wright. How you doing, Brent?
Hey Joris, doing well. I'm looking forward to spring.
Okay.
I don't know how the weather is your way, but we are just like all over the map. Freezing, cold, and then we'll have 60-degree days, and then back down to 27-degree days. But it's crazy.
Okay. Well, here Valencia is sunny today, so Valencia, Spain. But but the wind's blowing very hard. But yeah, we don't get to complain about the weather here very much. So, so I'm doing okay. I'm doing all right.
Well, and we'll be getting to talk to somebody, and I'm excited about this one. Niles Leonard. He's in Florida. And
Okay.
I mean, I know it's hot, but he can't really complain of winter weather. But there has been some cold snaps.
Okay. Yeah. So Niles, welcome to our podcast.
Thank you, guys. Thank you very much. I'm honored to be here.
So Niles, tell me, how'd you get it? How'd you get involved in orthotics and prosthetics?
Well, it was in college. I was working a couple of different jobs, trying to make money while I was doing my bachelor's of plant pathology. And about the time I was realizing that outdoor work wouldn't quite suit a fair-skinned redhead like myself, I got a job in our paper, in a local paper there at an O&P place. And it said, do you know how to work with plaster and do construction? And my dad does construction, and my mom is a ceramist, so it seemed like a perfect fit for me. So I went in there, started working, and it happened to be with Paul Krusakowski and the OP team. And it was such an inspiring and uplifting place to work. I started out, like everybody else, just doing a little bit of construction, building labs, pouring and stripping molds and all that sort of thing. But it hooks you. I got into it, got started doing more fabrication. And I remember I had one patient they let me work on. It was a little young girl, her plaster cast was about the size of a Dixie cup. But they let me go through the whole process of fabricating and making it. And then they let me deliver it to her. And I still remember that day. I still remember her patient number and everything. I handed it to her. She just kind of scooted over, snatched it out of my hands, put it on herself, and took off running. And after that, I was hooked. I was in deep. I knew this was the career for me. But I thought I was going to be going to O&P school like everybody else and being a practitioner. But I had started out, building labs and doing the work for Paul and making his labs. And, he was so encouraging and things that he let us build our own tools and put our own tools in there and things, because I had worked in, like I said, a lot of construction fields and things like that. And I'd worked in some cabinet shops that had nicer tools than the tools I'd seen in the O&P field. I was just absolutely baffled about the tools that people were using, galvanized pipes and all kinds of things. There was no structure really to the tooling. And he let me run with it. I had some friends who were welders, car guys and things. So I got together with them and started building tools. And because we had so many people going through the office, people really started saying, hey, where'd you get those? Can you make me some? And it really just took off organically. And I got help from Jeff Kingsley from Kingsley Manufacturing. One year at one of the Academy shows, he let me have a tiny little corner of his table. So I stood there in a suit that didn't fit and shoes that were horribly uncomfortable, and stared down everybody like a ham hock walking by if I was a hungry wolf. So I'm sure my sales techniques have gotten a little bit better then, but it really took off. We received great feedback from the field. It's such an encouraging, uplifting field. Everybody really is nice, through and through. It really is a great field. And we just got so much feedback and so much potential customers that I decided, instead of going to O&P school, I would go to trade school. I went to welding school and took night classes, and the rest is sort of history. It just went from there.
That is so cool, Niles. And I love that. Typically, will introduce your company. And I just completely missed that. I was so excited to talk to you and hear your story. But I love that intro because it really dovetails into where we go next. So, I mean, Niles, you've been hanging around this field for quite a while. And then it finally came to fruition, and it looks like in 2006. And for the last 16, 17 years now, you've been making tools. And the cool thing is with Niles is his tools, not only are they high quality, but I'm telling you, the schools are getting into this and seeing some of this. And so what happens is that these students, I don't want to say they get spoiled, but in a sense, they get to use tools, right, Niles, of things that work for them. And then they come out into the real world, O&P world, and they're like, what happened to the good tools here? Why do we have all this stuff that's kind of cobbled together? I'm really excited to have Niles on the show just to kind of discuss how important it is and then what a difference good tools make in that final outcome for the patient. So I hope that kind of does a little bit of justice to Leonard Industries and such, but we'll kind of jump in from there. So yeah, tell us about, okay, so what would you say from 2006 to now? I mean, there's been some massive shifts in technology and such, but this tool still for the most part, stay the same. What are you seeing as, and you can even refer to some of your best sellers and such, what are some of the pain points that clinicians, it doesn't matter whether they're digital or traditional, where are their pains and what are you doing to help them with that?
That's an excellent question. It's really multifaceted. So the change that I've seen is that the technology, really I was here sort of for the digital wave. We had a website in 2004 and we really started seeing, like I said, I was with the OP people. So we started really seeing the digital revolution hit O&P, in which case, how fast that has been. It's been a rapid uptake in technology with computers, microprocessor needs. The C-Leg was amazing and new when I got into it. Now it's, old hat. We've got all these sort of myoelectrics and just all this beautiful microprocessors have been integrated. But the tools we're still using for basic alignment and thermoforming and things like that are still designed in the 70s and 80s at best. As fast as all of the production, all the parts manufacturing has been going, the manufacturers aren't dedicated to tooling. So they've been trying to keep up with all the microprocessor revolution. And the people who are supposed to be upgrading our tooling are just focused elsewhere. And they were focused elsewhere before that. But I think as this digital revolution has hit, now they're completely unable to focus on tooling and upgrading tools, that we all use, no matter what you're using, digital or traditional fabrication means. And with that has gone safety. And that's really my pet peeve, is how unsafe fabrication has been in the O&P field. We don't have an orthotic and prosthetic safety standard. You can be an ABC, BOC certified facility, and all you got to do in the back is have some fire extinguishers handy. You don't have to have any sort of charcoal filtration for fumes. You don't have to have any micron filters for dust collection. So those are the sort of things where I think it really needs, tooling needs someone to focus on it. So I really just found a niche and have tried to bring it up as much as I can, bring up the quality of tooling technicians, bring up the safety measures available to technicians, really just sort of lift the back up. It's such a terrific field and we do such honorable work. And the people that do it deserve to have a safe, clean, healthy environment to do it in.
Is there a reason why this doesn't exist? Is it just an oversight? Is it like no company is focused on it, or
it's been too small of a market share? I mean, let's be real. If one guy can start this and do something, it's a tiny market share. And that's the thing, the large companies that do sell tooling, they also sell liners, arms, components, all kinds of other things. And so it's just a matter of focus and money. And it's really hard as a large company to put big dollars into an area that just isn't a huge part of the market when they have so many other parts that are just exploding in front of them. So it's really been a perfect storm, but, I love it. It's left me a great opening to come right in here and dedicate my life to building better tools, a system of tools for orthotic and prosthetic fabrication.
Niles, I'm just curious. I've seen there's a lot of kind of white papers or maybe even some just subjective data out there around the safety of O&P, specifically fumes and such. And there's been some stuff around women's health, right? Not the glue, the resins, trying to stay out of the lab and such. Do you know of any data, or what have you seen really over the last, 16 years or however long you've been doing this, as far as health issues when it comes to fabrication of these devices?
Well, I give a speech that I give kind of at different shows and to some of the colleges and things. But my second slide shows our current O&P standard that we have, our O&P safety standard, and it is a picture of an ostrich with his head in the sand. So far, everybody has ignored it. It's largely just been ignored. And when I got into it, there were technicians where it was sort of, it was like a pride thing. Like, yeah, I smoke cigarettes and use, alcohol and resins all day long. Some of them would say, no, you don't start a fire like that. You start a fire like this. And they would start fires on purpose. So thankfully, I think we're getting farther and farther away from that. I think the change in education requiring a master's means that there's a lot more people who are getting out of school with a lot higher expectations of the field and wouldn't really settle for that kind of stuff. And, the minute you bring them into the field, you've really got to pay attention to, if you're doing any sort of residencies or things, you can't have those two kind of schools of thought clashing. So I think it's really nice. In the last, decade, mostly I've seen a big push towards safety. And we were, building tools just for your typical fabrication, but always with an eye to safety. And we started to go out there and design and build some of our own O&P safety machines. But just doing a tiny bit of market research, we realized there are tons of machines out there. They're well in our price point, and they work fantastic for other industries. So there's no reason we can't do what we've always done and steal some technology from some other industries. For instance, the woodworking industry, you can have a safer setup in your garage doing your weekend woodworking than a lot of O&P places will have. So we've just gone out there and try and make the point of how dangerous it is to not be safe. You're risking your entire business, all your work. One little lawsuit, one OSHA problem oversight can really be a headache that can trip a business up. And with the safety machines and things out there being all within a couple of $1,000s, it's really doable, and it's really unacceptable for us not to push in that direction. And like you said, the schools have been the first people to pick it up because no one wants to walk into a dirty school. And as soon as the schools have picked it up, a lot of the people have seen, oh, this works in an educational environment. It will certainly work in our smaller, mom and pop type shops.
Okay. And do you think is there like a council for this, or isn't there like a group of people that implement this or something, or is that also absent as well?
You would think so. You would think no, we don't have it. It's a head in the sand type thing. So I'm out there just trying to push what safety features we have. In my presentation, I think that we should have at least a 1 micron filtration standard for, if you're going to be grinding carbon fiber, the dangerous particles are anywhere from 10 to 1 microns in size. So you want to have at least a 1 micron filter. For instance, the canvas bag dust collectors that everybody has, the big ones, you turn them on and they inflate. That inflatable canvas bag is the filter. And those have 30 micron holes in them. So basically, it's taking all the safe stuff that we could, would fall on the floor, we could easily cough out, and it's screening that out, but it's taking all the small, dangerous particles and circulating them through the air. It's actually blowing them all around the whole office. It'd probably be safer to not use the canvas bag dust collectors when grinding carbon fiber than to turn them on and stir up all that dust. So it's just, there's some really simple little things out there that we have not addressed as an industry. That are easy, doable, and would make a huge difference in the safety of our techs.
I think it'd be really cool to look a little bit more deeper. What else? Like you mentioned, kind of the resins and stuff, and the carbon fiber we know is dangerous. What are some other things that people should be mindful of?
Well, so we deal with a whole host of things. So we have fire hazards like everybody else, but all the acetone that we use, the resins that we use, those are fire hazards. So we've got those. We have the storage issue with fire, which everybody, if you're good on safety, you've got yourself a nice fire cabinet. The problem is they take those dry bags of organic peroxide and they throw them in there on the bottom. So if there is a spill of some of that resin, it gets too hot or something and it overflows, you've got the worst case scenario. You've got a tiny bit of resin landing on a huge pile of catalyst, and that's where you get big exothermic reactions. So we haven't even gotten into the point where when they send you the little bags of, your catalyst for your resin, to store this in a dry, cool place away from all of the other things. So I've been even getting into promoting for fire safety, having 2 fire cabinets, a large one for all of our liquids and a small one up above it for all of our dry powders. So we don't have any problems with that. We have biological contaminants. We're dealing with a fresh prosthetic right off of a person. So we have glove issues in the back that we don't deal with. There's nitrile gloves that are suitable for mechanic work, and we have latex gloves that are suitable for human contact. We really should be wearing both because you're going to take this fresh prosthetic that might have sweat, blood, any sort of bodily fluids on it, and you're going to spray it down with acetone. So no matter which pair of gloves you have on, you're really not prepared for whatever's happening. We really need to have 2 sets of gloves when dealing with fresh prosthetics. So I address that. We have the, like you mentioned, the fume issues that we off gas. If anybody's ever opened Sequel Hearts in the mornings, you know what that, can do to your day. All the smells that we give off, a lot of times we have patients that have, immune compromised, things like that. And that can be difficult for them for the fumes. So we really should address that. And then, of course, we have the dust. Our tools are designed for hollowing out wooden sockets. That's why we have those long arm reach grinders, is they really help us get in there for hollowing out wooden sockets. Well, we've come a long way since that. And now our grinders move right into grinding composites with carbon fiber, and the tooling didn't change a bit. We still use the same sandpaper that you would use for wood. We still use the same speeds that you would use for wood. And those are, 100% not compatible with each other. And like I mentioned, we're still using the same safety equipment that we use for wood back in the day, and that has not kept up with it. So really the safety for O&P fabrication is a nightmare. And, I always address all of our topics as if OSHA were looking at us, because that's going to be one of the big agencies that would come in and give us oversight. So I always do my presentation as from the eyes of OSHA. How would they look at us? How would they change what we do? How would they, worry about what we have, and try and get ahead of that, so that if they ever did come into the office, at least we can say, here are the problems, and we've addressed those problems in this way.
Well, why don't you do something? This is just an idea, right? I mean, why don't you do something like the Safe Prosthetics Foundation or something, and just ask people to get, pay $500 a year or something to get certified, and you do like a training, maybe a site visit or something like that, and then you could kind of, get paid to make everybody safe or something like that.
I would if I wasn't so busy making alignment jigs. They've kept me so busy filling this tool gap that I have honestly, if you look at our website versus what we actually make, you would know how terrible we are at getting pictures of our high quality stuff out there. We sell so much by word of mouth, and we have a lot of repeat customers. Once somebody starts with us, every time they upgrade their lab, change a fixture, they always come back, because we do a lot of custom stuff. If they have a corner that needs work fitting in, or they need something that's got a shorter nose or taller, any of those things, we're easily able to help them, because in O&P, so many things are custom. Having one size fits all fabrication hardware makes no sense when you've got so many different sized people, let alone how many different sized devices we're doing, from upper extremity to a large AK. The volume is 100-fold, 200-fold. So that's sort of where we've come in. And I wish we had the time to do more of that. There is a lot of room for upgrading the fabrication area of orthotics and prosthetics.
Okay. So tell us a little bit about all these tools you make. A little bit more about, first, how did you get started with just doing tools? When did you think, I'm going to do only tools as a business? Was there a moment, or did you kind of drift into it?
Yeah, it was at that show. I really realized how many people were, you go to the O&P show, the national shows, AOPA or the Academy, and there's, how many different liners, how many different feet, how many different foot orthotics, lots and lots. There's no tools. How did we make all this stuff? Sometimes Phil Auer brings something. Sometimes the table showed up with his, one giant, large, one size fits all kind of fixture. But no one really focused on those, and no one made them super quality. We were using galvanized pipes and things like that, which have lead and zinc and all kinds of. That's not a suitable medical fabrication material. And like I said, I just had a background in construction and saw all this. And what we didn't have is a full set of fabrication hardware, something that works through modifying the plaster cast, thermoforming the socket, cutting and sanding the socket down. If you're doing any of your laminations, whether you're doing pre-preg lamination or your traditional wet lamination, there wasn't a whole set of fabrication hardware that then worked with the alignment jig. And that's really where kind of the rubber meets the road. You can have a great socket design, perfect suction socket, but if you don't get that foot and that block aligned in the right spot, you're going to be chasing your tail the entire rest of the time. So getting that alignment correct was always tough. And when I was working, you get everything set up, and then you have to take the pipe collar off and mark it with a Sharpie. And every time I did that, I know we're losing rotation and height. We're just losing alignment. And rotation can be very difficult. If you're off just a little bit in rotation, you got to put a rotating block on. The pyramid doesn't really help you with if you're off in rotation. So just being frustrated by that. And I had to start slowly. It was kind of a one-man band. I went to Phil Auer, Otto Bach, all the big names, and showed them all these beautiful ideas I had. And lo and behold, no one was willing to trade in their flagship pieces that they'd been making for years for some unknown kid that said, hey, I can do this better than you guys can. And so it got frustrating. No one was willing to hire me. I knew I had a good idea. I'm too dumb to quit and too stubborn to stop. So, like I said, I went to night school and started making it, and it just evolved. Once we started making one set of tools, everybody said, great. If you've got thermoforming tools, I need laminating tools. If you've got laminating tools, I need grinding tools. If you've got this, we need safety equipment. And so now we're just trying to cover all of our customers' needs. When people call, a lot of times they're really quite intelligent people, PhDs and things, setting up these big labs and large facilities. But their specialty is not what size compressor should you use. You ask them what voltage, the construction and team, installation team asks them, where are you going to need your outlets? How big are they? You might have a PhD in orthotics and prosthetics, but you might not know the first thing about, the compressor size, voltage and things like that. So we've kind of tried to come in there and make sure that all these schools and big facilities that have really intelligent people and are making high quality orthotics and prosthetics have the tooling in the lab to match that. And so my construction background has just sort of come in. I'm very familiar with electricity, plumbing. I mean, I built my own house from the ground up. And so it just has sort of evolved into this whole lab thing where now not only are we building the tools, we're actually got 3D modeling software where we're taking the space that these labs are filling up and we're able to put everything in three-dimensional space and scale and walk through it, make sure we're ADA compliant for all of our walkways, make sure we've got all of our outlets all laid out and things like that, so that these places can really, take advantage of the space and the budget that they've been given.
So Niles, on the stuff, I know that, and just because we've got some of these in our office now, but tell me what you've done to like the lamination stuff that's been different, and I think better than previous iterations or previous somebody's homemade stuff. Talk about some of the bases, the interchangeable bases, the rotation. I don't even know what you call it, the double gasket thing for inner and outer bags, all that stuff. I'd love for you to share some of that with our listeners.
Okay, yeah, absolutely. One of the things that is always plaguing O&P facilities is space. We're always tucked in the back, no windows, no ventilation. So making parts that are modular was a big thing for me. We have the same 4-hole pattern for all of our bolts. Anything that bolts down has the same pattern, which lets everything work together. But then we also have interchangeable tops. A lot of times you've got vacuum hooked up and let's say you're going to be bubble forming a check socket. Well, that would usually be a dedicated bubble check forming area. What we did is made the base stay there, the vacuum stay all hooked up, and you can actually pull the top out. So now we can put in different size check socket platforms, all the way from a 4-inch for upper extremity, all the way we have an extra large AK that's 16 inches wide. But you can interchange the platforms, and you can now interchange with a lamination fixture. So the same tiny square footage of space, you can have both laminating and thermal forming without having to unhook the vacuum and rehook everything up, and basically put just different heads on your vacuum fixtures. Then we have dual fixtures, which will actually have a lower independent horizontal drape thermoforming chamber with a vertical chamber on top of it that allows you to put in check socket platforms or laminating fixtures or anything like that. So you can really get the most fabrication out of one space without having to move your vacuum and hoses and lines. And then we did all the small things. Make sure that every line, every chamber has its own valve on it. Nice, easy to operate ball valve, so that it's easy to use, even if you've got big, bulky thermoforming gloves on and things, so that you can just turn your vacuum pump on and then independently operate each one. And then laminating. I couldn't believe that we were using a pipe with a hole drilled in it for double bag lamination of a carbon fiber prosthetic socket. I mean, it's such an amazing piece of engineering when it's finished, and to think that it comes off of a galvanized pipe with a hole in it was just ridiculous. And as a young technician, I did all the same sort of dumb stuff that everybody else does. You've got a perfect, lamination. It looks great. And then you go to take it off, and there was a big hole in the back that you just couldn't see. So we made fixtures that rotate once they're in the vacuum, so that you can stand at a table and still rotate the fixture 360 degrees, work on a prosthetic socket from all sides, not have any of those problems. One of the other things we did is we added 2 valves for our laminating fixture, so that you have an inner and an outer bag valve. And that was nice because, like many young technicians, I had screwed up and pulled the tape too early and let the vacuum go on the inner bag. And you don't know this until you're all the way finished, but you go to peel it out, and now there's like a wrinkly texture on the inside of the socket where the patient's, leg is going to be, their liner is going to be. It's totally unacceptable. Again, you don't know this until it's all done and you put in all the work. So we sort of tried to take out all of the common problems that you could have and make it easier on the technician, make it more profitable for the practitioner. Just have tools. It's so hard to do a good job with crappy tools, and it's almost hard to do a crappy job with really good tools. So we just tried to make them the best that we could. We have nice big pulling surfaces so that it's easy to tie off the first bag. We have a kind of a fixture that's got 2 stacked donuts on it, so that you get this great outside valley that you can just pull your outer bag over and just tie a stockinette in. It's really easy. You never end up with leaks. You never end up with screw-ups. We've got areas to tuck extra stockinette and laminate material so that you don't have any of your layups ruining your vacuum on your PVA bags. Just trying to take out all the little problems that technicians have just to make the workflow a whole lot smoother. And then you pair that with everything works with our alignment jig. That pipe collar that's on the alignment jig stays on your cast through all the different fabrication. Our laminating fixture's got a big enough, wide enough mouth that it slides right down in there. So do all of our thermoforming fixtures. So even if you're doing like a P-Light liner and then you're laminating over it, your pipe collar stays with it the entire time. Some of the things that we've done for our alignment jig, and that's really kind of our flagship piece. And that was really tough for us because I really just wanted to redesign the Hosmer jig. I love that Hosmer jig, the BFJ. I think it's just fantastic. I did also really like the old Autobach one. And I'm a tool guy, so every time I'd go into a new lab or an old lab and anybody's got something different, I have to play with it. I have to touch it. And I loved how rigid that old Autobach alignment jig was. But you have to move it with a forklift. It's a beast. The handles don't work. It's hard to use. It's not as easy to use. Whereas the Hosmer jig is fantastic, easy to use. It articulates really well. But it just wasn't... the materials that it's made out of don't last as long as I think they need to. It's not as accurate as I think it needs to stay over a length of time. Tools have to last for a long time. I like hammers, made out of steel, axes made out of steel. So we went down that same path and we made our alignment jig 100% out of steel. Even the handles, there's nothing plastic or wood or anything about it. So it's a very tough fixture. But because no one's willing to adopt our design changes, we kind of had to make a fixture that everyone could use, because you're not going to get people to do new training, as you know, Brent, in the O&P field. That's a tough one, selling them something totally new. So it had to work like the old one, but still have all the added function that it needed to have. So that was really a tricky line to walk. And, we're still always improving it. We still take customer feedback all the time. And we've got a whole new model coming out that's taken into account feedback from all over the world, from all sorts of different people. And, if somebody calls up and has a great solution, that's perfect. We're going to do everything we can to put that right into the fixture, which is something I don't think the other companies are able to do with their size. So that's, one of the things that I like that we do.
Yeah, I love that. Can you tell me just a little bit about, so the fumes that we deal with in O&P, right? And then just some of the safety considerations around the different types of fumes, whether they be glue or resin. You've got your tabletop level. Do you pull them up? Do you pull them down? Do you pull them at the same level? What are some of your kind of rules of thumb for that?
Well, that's a good one. Fumes is, I think, one of the least paid attention to areas in our field. Typically, all of the infrastructure that you were able to buy was basically just an air mover. So you'd cut a hole in the building and you'd blow it out in the break area. You're outside smoking a cigarette, you're going to smell acetone. That's just the way it went. But that's unacceptable in, for instance, a VA inside a hospital. There is no exterior that you can vent to, and you can't take dirty air all the way through a hospital and blow it outside. So you have to deal with this kind of stuff on site. Thankfully, as technology has come up, so have a lot of other industries. So we borrow this from a lot of the laser cutting and a lot of welding creates fumes. So this is partly welding industry and kind of the laser cutting, plasma cutting industry. And these are fume extractors, which have articulating hoods, so they get right into where the problem is. And it's a really simple solution. It's a large fan with a big bag of activated charcoal. That's all it is. It's nothing crazy, and it draws the air over the charcoal. All the fumes and all the organics get stuck inside the charcoal, and it blows out clean air. You can tell they're working because you can't smell what you're working on when you're working on it. So it's a terrific solution. They're about $2,500 for a little portable unit with an arm. You can roll them all over. I like them because you can leave the hood over your laminating and gluing area, but it is portable, so you can kind of unhook it from the arm and roll it over if you have a fire cabinet you want to suck the fumes out of. They're just really handy. They're not that expensive, and the safety that they provide is just great. And plus, you don't have to cut a hole in your building. That's big for infrastructure. If you share space, if you're renting, any of those sort of things, cutting a hole in the building just might not be an option. So having these portable fume scrubbers. I like Fumex out of Atlanta. They've been a real good company. They have a couple of different models. They're always fast, great customer service, U.S. based. We try and stick with as much U.S. based stuff as we can.
And
as
is
a US
that
manufacturer?
okay? You guys are also a U.S. manufacturer. Is that also a problem that your costs are higher than other countries? Is it something that's increasingly difficult? How do you stay ahead as a U.S. manufacturer? Today.
It couldn't be much tougher. I mean, our government does very little to help entrepreneurs. There's very little tax break. In fact, you started a business, good. Here's all the taxes you have to pay. Keep track of them and pay us. And if you do it wrong, we'll take you under. So I think that there could be a whole lot of help from the government. I think all the problems that we have as a U.S. manufacturer can also be offset by our supply chain availability. We really have a lot of stores and a lot of delivery services where you can get anything you need at any time. So it allows us to do good prototyping and things. But selling to the world is tough. Everybody has taxes and tariffs on our import goods. And so it's tough when you're trying to compete. So our next big phase is trying to get some international distribution, trying to get some people that would like to take some stock and take these into some other countries. We do a good bit of international sales just from the website. You're able to purchase things right off the website, and that has really done us well. but we'd like to be a little bit, more official with everybody. But it's a tough road to climb. We're competing with 100-plus-year-old companies. As 16 years is a lot, but not when you're up against 110 or 120. So that has been an uphill battle.
And do you think that do you think you can be faster to market? You can spot trends faster. You can ship faster and innovate faster, or do you actually, are you like, I have to innovate because otherwise I'll be out of business next year? Is that kind of more like?
No, I don't think we have to innovate. I think we are innovation. There isn't any of our products that aren't really innovative, and we're always making them better, keeping going. That's sort of my passion for it. So, updating and if we find a better powder coating or if we find a better steel, there's a lot of internal stuff that we do, and we just put the best tools out there. We price them according to what we need them to be. We really don't price according to what anybody else does out there. We're kind of on our own little independent island, and so far it's worked for us. There's a lot of room to go, but so far it's been great.
And as for your we do a lot with digitization and 3D printing and that kind of stuff. How about you? Is that something you're tempted to use, or is that something you're staying away from because it's not useful for you?
Oh, I love it. I love it. I think fighting technology and fighting the future is just swimming upstream. There's no sense in it. I use the new 3D modeling software. I have a new program that I absolutely love that lets us build all of our products to scale down to the thousandth of an inch, and then put them into anybody's floor plan, their layout. It lets us really show the customer, here's what 10 workbenches side by side would look like. Here's what your oven area is going to look like. Here's your ADA compliance to make sure you're right. So I love the digital sphere. I love scanning. I love 3D printing. I love what Brent's doing with it. And I love that because he's doing things you can't do with traditional fabrication. I don't think 3D printing should try and even compare itself or be in the same, conversation as traditional. I think it's just another way to do things. I think, probably in 50 years, we won't see plaster like we do today. Like 50 years ago, we don't see wooden sockets like we did 50 years ago. I have still worked on a couple wooden sockets, and I bet in 50 years, people will still be going, I have to have my thermoplastics, So I think that 3D printing is here to stay. I think that the scanning portion of it, I think O&P will use it as it sees fit. I don't think that any of the 3D manufacturers are going to get everything they want. I think that the practitioners are going to do what they've always done and take the parts that they like from different technologies and bring that in, and then they'll leave the rest. I think that, scanning all of your old sockets before you smash the plaster would be something that everybody should adopt. And then that way you've always got your model references safely stored if you need them. But, asking people that have 20, 30 years of experience to learn new tricks, that's a tough one to do. So I don't know that you're going to get quite that many people to do it. And then the field is also very hands-on. There's a lot of true artists in this field. The leather work and things like that, that's artwork. And so the digital thing, I don't think quite applies to as many of them, or they're not as comfortable in that sphere. But as the education changes, we're getting a lot more people that are a lot more comfortable with technology and things. And so I think it will just naturally work its way right in. And like I said, I love what Brent and others are doing with designing and building things that can't be traditionally fabricated. I think that's where the 3D space will really excel, is it will really work for, cases where it just will be the best outfit for the patient.
Niles, thank you so much for this. This is a really, really great journey and looking into kind of area we don't get to look at often. And thank you so much.
Absolutely. Absolutely. Such a pleasure to be here. I love speaking with you guys about this. I love everything O&P. So, thank you guys. Thank you very much.
All right. Thank you, Niles. And Brent, thank you for being here as well.
Oh, this has been great. And thank you for sharing your story, Niles. And just curious, Niles, for people to find you, what is the best way to get, is it your website? Is there, what would you like people to know how to get up with you if they want to know more?
The website, leonardindustries.com. That's, a very good place to start. You can always email us at sales@leonardindustries.com. Feel free to give us a call. I love talking with all the OOP people out there and really addressing new issues. So anyway, you'd like to get in touch with me, if you want to find me on LinkedIn, Niles Leonard, that's a great one too. And keep up with all the posts and everything.
Awesome. Well, thanks so much.
Absolutely.
Right.
Thank you, guys. I appreciate it, Yoris. Thank you, Brent.
And thank you for listening to our podcast. This is another wonderful episode. And you have a great day out there.